All right, so I'll go ahead and start recording, and we'll go ahead and get started with our lecture today. So today's lecture is going to be fairly easy. I'll reintroduce myself. I will then introduce how to use the textbook, our free textbook, right? So if you haven't been signed up for it, I'm going to go through the directions on how to sign up for it, like in 5 minutes, and then we'll go through Then we'll go through a project in the back of the textbook, which is suitable for just starting out. I guess I can start here. I like games a lot. I love video games. I love board games. I love puzzles. I love all sorts of games. I love games that have simple rules that create a wide variety of complex play. I love games that have deep rules and complex rules that end up being quite difficult, like some of those big strategy games like Solaris, Hearts of Iron, the Paradox ones. I enjoy games like RimWorld, one of my favorites right now. I enjoy games that are difficult, Elden Ring, Dark Souls kind of stuff. I enjoy the Mario stuff. I enjoy Tetris. I enjoy a lot of games. I even enjoy shooters. I love FPS games. My favorite FPS games, mind you, are the ones where you are cooperatively competing against the computer, right? So games like Killing Floor, which you're a six-man team against a wave of zombies. I find that tends to be a lot less toxic than, say, Call of Duty lobbies. Mind you, if I ever need to be insulted, I know to go into a Call of Duty lobby. But But I love games a lot, and I love games where they kind of throw you into the game and say, here's the basics, and you're going to pick it up from here. And I enjoy that somewhat. It's not for everybody, I understand that, but I have a personal preference to that. And so you'll be seeing that a bit in our project today, which is that there's going to be a lot of complex code, and you're not expected to understand it at all, to be honest. All you're expected to do is change one number to another and push a button. That's all you're expected to do today. So if you see that code and it makes you a bit worried, just remember that's all we're doing fundamentally today, which is we're changing one number in a line to another number and then pushing a button. That's it. So on the off chance that you were not here on Tuesday, I am Professor Rosen. I am the teacher for this course, and I also happen to be the advisor for a bunch of programs. So if you have questions about academic advice that you want to be answered, I can answer some of those questions. Not all of them. Like if you're trying to ask me about programs in the English department, probably going to be less able to answer those. But if you have questions about this department and a bit more broadly science, especially the biology stuff and physics stuff, because I have to collaborate with them. Yeah, totally. I also I have also taught twice now at the Temple University's Japan campus. So if you have questions about that, I'm more than happy to answer those. Now, again, if you did miss the lecture on Tuesday, you can go over here. So this is the front page of our Canvas. All the important stuff is here. Lecture recordings are over here. So just click on this button or go to the other important links, which I will go to in a second, and you just click on the lecture recordings links. This over here is a playlist. So all of our videos will be in this playlist, and then all the previous semesters, which will make a better example, will be here. And what you do is you can either hit play, you can hit watch on YouTube to have it pull up on YouTube, and so you can have that more native experience. And then on the top right is a button, which will have all the lectures, and I'll try to keep them in order. But that's how you can select what video you need if you want. And these are useful not just if you're sick and missed a lecture, but also if you want to review the material. Right now, we've only got one in this playlist, but it will grow as I upload them. I do try to upload them the same day, but sometimes I forget until the next day. But if you need it uploaded sooner, just don't be afraid to poke me, So let's see. Oh, and again, the reason I keep this on YouTube is because YouTube is extremely accessible. If it's down and you can't see it, it is not my fault. It would be rather impressive if it was, but the thing I do dislike about YouTube is the ads, on YouTube and a lot of that. So I do recommend installing a ad blocker on your web browser. I use uBlock Origin for mine. If you just look up ad blocker or message me on Discord, I can help with that. It's a bit harder on Chrome these days, but you can still get something. But that would help with basically having to deal with the 5 to 30 second pre-roll that they're going to hit you with. I don't like that. It used to be that I could get away with not having those, but I mean, I've also been having an ad blocker on my machine for like 2 decades now. So anyway, it makes browsing the web a much cleaner experience. All right. And finally, if you haven't yet, feel free to join the class Discord and ask questions there, okay? Now, our textbook, right? If you went to the bookstore, you may have been surprised not to see a textbook. Again, I don't really like the textbook industry. In fact, I'm currently writing a textbook, and it's taking me a while, but it's in collaboration with Temple Libraries here, North Broad Press. And the plan is that we're producing it at cost, and it's going to be online for free. I hate the textbook industry with a burning passion. I went out of my way throughout grad school to questionably buy international copies that should not have been sold to me, so that I would be able to pay a much more affordable price for them, because I don't think it's right to shell out $120 to $150 to $200 for a textbook. I can understand and justify a $30 cost, right? That's justifiable for something in hardback. But for a textbook to cost almost as much as a low-end computer, no thank you, right? So that's part of the reason why I'll be using this online text. Now, that being said, it does have a few quirks that we will encounter later during grading, which is that there's going to be a grade me button for your assignments on the textbook, and that will disappear later. But don't worry, just because it has that grade me button disappears, it doesn't mean that the stuff will get graded. I will explain that later, but suffice to say, if you do work in the textbook, it's going to get graded. Don't worry about that. Okay, so with that, what you'll want to do if you haven't already is to sign up for the textbook. The code you need is this code. Fall 2025 Rosen. And all that does is that makes you're enrolled in my class and can get scored. That's all it is. All the stuff on that website is free. This just simply makes sure that you end up with me and for this semester, hence the fall 2025. Okay, so you go to runestone.academy. If you're logged in, great. If not, I'll go ahead and log out. Log in / register and get started if you don't have an account. Right? Next steps, take me to the sign up page right over here on the bottom. Right, once you hit the register and sign up, you go here to so once again, I'll do that again. You hit this button over here, the register and get started. And that unfortunately does bring you to a page where you have to click one more thing. Annoying, I know, but. And here's over here where I discussed this yesterday. You can put in whatever username you like, that the username does not matter. And then you need to do one of two things. Either put in your first name and last name as it appears on Canvas, or put in your TU email address. Like for me, that would be tu85861@temple.edu. And the reason for this is that I have a Python script that merges the gradebook from Canvas with the gradebook from this together, so I don't have to copy line by line throughout the semester. It's annoying because I get students who accidentally make multiple accounts. I get students who drop the class, so there's all sorts of inconsistencies between the rows in the two textbooks. So it's not as easy as just simply giant copy and giant paste. I have to actually match them up, and I do try to match them up by first name or last name. Oh my, that is awful. Let me fix that. Sorry about that. That was awful. Okay. First name, last name, as it appears on Canvas. or your TU email over here, not the alias like andrew.rosen@temple.edu, which is what you'll email me as, but like the industrialized number that you get. So then your password, obviously, just don't tell me. I don't care. Just make it something that you can remember. I can reset. I believe I can send you something to reset your password or whatnot. But and then just over here you'll need to put in the course name, and that's Fall 2025 Rosen. Okay. You might think to yourself, oh, if I make my own course, which you could totally do, that'll give me the answers. That will not help you unless you already know Python, because a lot of this works is by auto grading and doing, and that's its own programming language using unit tests. It's done in Python, but it will not help you. But there's nothing stopping you from trying it. Seriously, there's nothing against it. Again, the stuff we do in the textbook is going to be low stakes. Now, once you're signed up for it, right, you can just simply log in if it doesn't keep you logged in. And it should bring you to your most recent course in this book, course in this website, which is going to be this one. It'll tell you, hey, here's the instructor, and here's the textbook itself, and you'll have a list of assignments. There's a bunch already, but that's because I just simply import all of them. Quiz 5. I'll probably have to take that off. I don't actually do the quizzes. I have to go through and apparently miss these, but the ones you want to see go through are basically the chapter 1 stuff, which is kind of basic stuff about Python. Okay. Let's see. But to actually get to the textbook itself, you click on Back to Textbooks or Foundation of Python Programming. And this gives you the textbook. Now, from this previous page, this does give you the assignments as what to do. And I'll click on that in a sec. You can also go up here to the Meeple icon, the little icon of the person, and then click on Assignments to get to the things that I assigned. That's why. There we go. Okay, so those things are hidden. Okay. And yes, it looks like a lot, but remember, these are soft due dates. As long as they get done, they will get graded. So this is the entire textbook. It goes through chapter by chapter. We're not going through the entire textbook. We will go, I think, through chapter 12 with a little bit of 14 smattered in there. The big important thing that you're going to be relying on the most in our lectures is this appendices at the back, which is the project list. Okay? But as far as what you need to do with this textbook, let's look at the thing with the nearest due date, the two things with the nearest due date. You've got chapter 1 readings and chapter 1 exercises. Let me go ahead and open these up. Chapter 1 readings will show you, hey, you haven't read these things yet. And it will basically track, hey, did you read these things, interact with the boxes on the page, right? You could obviously just speed through it and cheat the system by just kind of going click, 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 we're done. But, I give these readings for a reason, which is that I, think that they're important. Now, as I've alluded to, one of the reasons I like this textbook, I alluded to this on Tuesday, one of the reasons I like the textbook is because it doesn't just have the code like a normal book and just says this is what the output is. You can actually run code in the browser. So I could do hello Alice as opposed to hello world. I can change the code up and it will give me a different result. And every time I hit this button, I can change between what I previously had there, which is nice. I can also, and this is good for our exercises, I can also share the code with you. And so it will appear as a sample in this timeline. So those are the, so the readings from the textbook, very easy to keep track. Now, exercises. This is probably the most important part because I don't want to stress you out too much, and this is to avoid giving you stress. Just like your math class, right? typically math class, they have a big textbook, like from calculus or pre-algebra, and then they say, do this selection of problems from the back. Not all of them, just do this selection of problems, right? Because they've got like maybe 100 problems for that chapter, right? Just like that, we have a ton of problems in here. We have tons of exercises for this. Let's go ahead and look at, let's see, yes. Chapter 6, there's tons, okay, no, and contributed exercises. That's where we see most of them. There's tons of exercises. Why is it not going to the next one? Oh, I guess chapter 6 doesn't have a lot. What is it that had a lot? I feel like, oh, yes, here we go, chapter assessment. So there's tons of questions over here, and I don't want you to have to do, you're not going to do all of them, right? So some students, they make the mistake early on thinking they have to do all the questions in the exercise section. That's not the case. To know what questions you have to do, you go to assignments, or you click on the corresponding assignment on the page that you open up, like over here to chapter 1 exercises, and it will tell you, hey, these are the questions that I care about, and it'll just show you the ones. So you don't have to look them up, they're right there on the page. Got it? Right, so you don't have to do all of them. If you do happen to do all of them, the ones that were of the subselection will get graded, so you know it's not like you have to redo your work, but still. So this number over here will get updated when I run what's called the grader. And this is the one quirk that I think throws students the most. When I run the grader, which automatically grades a lot of the work, it will give you a number here. And then that number is not going to change after you do, if you get one wrong or something like that. It's not going to change afterwards until I run the grader again, right? So that's the one thing that is annoying for students. It doesn't automatically update until I tell to update. And I don't necessarily update it as frequently as students would like, simply because it's a long babysitting process on my part. I have to go chapter by chapter and hit the run on it. And then running, depending on the traffic to the website, can take anywhere from a minute to 15 minutes, depending on the chapter and how many people are utilizing the website. Like, because this is not just us, it's throughout the country that are using this. But if you do need those grades updated for a peace of mind, let me know, and I will do my best to run it. Just when it comes to week 5, when I do make sure that this runs so that I can give midterm evaluations and stuff like that, and midterm warnings, that I can have something for you. All right. So if you have any questions about the textbook, let me know, but as long as you're signed up for it, we can now move on to the next part. Now, the way we can always find the project that we're going to be working on, because we do work on a lot of these, is you can do one of two ways. You can go to the module, and we'll be doing approximately one module a week. And if you haven't clicked on the overview for a module, it basically says week by week what we're going to be doing. Module 1 for week 1, module 2 for week 2, module 3 for week 3. These will link you to this exercise page. And then over here, I had to change the URL to be the fall semester, and I have to go through and do that for all the links. But it will link you to the project that we're going to work on. Okay, so this is method number 1 of how to get to what we're going to be working on today. And this holds for all the other sessions we'll be holding. So you just simply click on it, and it'll go to the appropriate project. Alternatively, right, you go to the textbook, right, which it looks like, right, which from here you click on this, Foundation of Python Programming, and then to find the project that I'm referencing, you just follow me and say, okay, we're working on preview of an end goal, project 1, and you go there. So go ahead and, if you are on a laptop, go to this. Now, if you are not on a laptop, make friends with somebody and just sit next to them. Seriously, it's okay that you don't have a laptop. If you do not have a laptop and you want to have one, like to own, speak to me and I will help you find, an option. If you want a laptop but for some reason you can't, right? because maybe it's out of the price range. You can always borrow one from a kiosk. You can always work on these on your phone, although it's a bit of a pain. Tablets, totally, you can do this on tablets, right? But if you need an option for doing this at school, let me know. But worst case scenario, just pair up with another student and do it later, or tell me that you did it with somebody else and I can give you credit for it, right? So I just do want to make this as seamless as possible for everybody. Right. But for the most part, like, it's not necessarily required, just makes it a lot easier. But again, generally I don't have to say bring a laptop to class because pretty much everybody does these days. They bring their nice big distraction machines to class. All right, so preview of an end goal. Okay, so the author here goes on about how computer programming can be a very extremely rewarding experience and how you can do a lot of things with computers. And that's true. I enjoy computer science because it allows me to tackle a lot of puzzles. Like I said, I like games, and generally if you like games, you have a tendency to enjoy puzzles and picking apart problems that bug you. There's a lot of things that you can do with computers. You can make them understand, like it says, human speech, image processing, animation. Like, there's a number of movies that have been made. There was one movie, Flow, that it was a dialogueless movie, featured a cat. That was all made in Blender, and Blender uses a lot of Python plugins. You can do tons of stuff with code. But, as I mentioned on Tuesday, this class, in terms of the kind of work you need to put in, we often use math as an approximation for computer science, at least for intro to programming, because the problems we tackle here are most analogous to word problems. But what you really need to do is more like a music class where you practice and make mistakes. You practice a single line. Or if you've done martial arts, right, move your body in a certain motion until you can just do it reflexively. Okay? But it's good to see where we plan on ending up. Okay? So one thing you do need to know is that your computer is an evil genie. It will do exactly what you tell it. Exactly. Won't do what you meant. It will do what you tell it. Right? So, and that's important to understand here. You will do it, and it will make you feel like an idiot. You are not an idiot. You're human. Okay? That's very important to understand. There's a lot of times where you will go, I am dumb. I am an idiot. I made a mistake. How could I make such a simple mistake? How could I not see it? You're not an idiot. You're human. Your eyes, which is what you're going to be using a lot for reading your code, are designed for doing things like keeping you alive from high-speed moving objects. That's what they're really good at. Reading's just kind of a task we picked up on, it's a fun trick we've picked up along the way. So you get so your eyes are easily tricked by stuff, okay, all the time. Doesn't help that you're basically blind in a couple different spots in your eyes, and your brain does a great job of masking it. But, yeah, it's tricky. So don't get discouraged. If you get stuck on something, ask me. Okay. But what we're going to look at is kind of trying to demystify what programming looks like. Now, a lot of this is going to be a lot of, I don't understand this necessarily or how this works. But what I'm trying to show you is that the grammar and the words are English, and they follow a somewhat English syntax and ways that they're going. They're things that you have to learn, but you learn it over time. So let's go ahead and take a look at this first program over here. And it will convert a color image into black and white. Okay? That's what this program will do. It will take an image and will convert it into black and white. So we're going to read through this and kind of try to understand how it works. Kind of demystify it. Now, this is important. People in the back, are you able to see this? Or do you want me to make it bigger? Because I can easily make this bigger. Yes? Yeah, bigger? Okay. Okay. So, import image. The Python library, namely there is something, I should actually explain that. There is something called a Python library. Python isn't, as itself, it has its own programming language with its own basic kind of things you can do. But there's a lot of common tasks, such as I want to run a web server, or I want to play with math, or I want to do image manipulation. These are a lot of common tasks, and if there's one thing programmers hate, it's reinventing the wheel. So a lot of these things so a lot of these tasks are stored in what we call libraries. And you can access these libraries by using what we call an import function, to import these functions into your program. Now, the reason that they aren't all automatically loaded into your program because you might need them, and you have to specify which ones you need, is because there's a crap ton of them. And it would make any program that you make extremely bloated, and you'd have to make sure you didn't want to accidentally name one of your own programs something else. Okay, so we just kind of import what we need. You won't know how to do which ones you need yet, but for the most part, in this class, we will be working with, I think, we will be basically using only two in this class that I can think of off the top of my head. The first one is random, which is it will look like import random, and that's for generating random numbers. We will be tackling that a little bit early on, just kind of as an example for how to do imports. But later on this semester, when we get to cheat at hard mathematics, that's when we do a lot of randomness. And the second one is turtles, which is what you're going to be working with more, which is just simply the turtle graphical library. Easy kind of way to visualize how your code, like literally visualize how your code is moving. All right. Def process 11, and then IMG. So a lot of programming of working a programming language is making up your own words. Specific words, namely verbs. Okay? Now, I liken them to verbs because these things do stuff. Process 11 is going to do something. It's a very poorly named function, verb, but it does one thing, and that thing was convert an image from color to black and white. That's what this verb does. Okay? So def is short for defined function. Functions are your verbs in programming language, and they are akin to your mathematical functions, only they can do quite interesting things. You might also hear them referred to in other languages as procedures or methods if you're coming from Java, right? Because we do have people who are from other programming languages. And those words have slightly different implications, but they are all verbs in a programming language. Okay? So process 11. Open parentheses. This is what we call a parameter, or is an argument. Honestly, I actually have to write that down in my textbook because I forget the difference all the time. But this is a way of saying, let's go ahead and take in an image that we're going to work on. The colon basically says everything that's indented in this is going to be part of the verb. It's going to define what the verb does. Okay? So everything, and what do I mean by indented? I mean having all this white space ahead of us. We will get into this later. This is not something you really have to worry about. Again, this is all about demystification. Okay? If you think you have to have this all memorized for the first exam, don't worry. You could miss this entire lecture. Again, this is entirely demystification. Python, unlike other programming languages, assumes that you're going to try to keep your code nice and neat and takes advantage of that. So it uses colons to say, hey, this is part of a bigger statement, this is part of a bigger verb, and everything that is indented, right, with like a tab or a spacing, is part of this verb. And we'll see that basically you get further indents to say this is part of a bigger statement. Now, we get to this nice colored green stuff. Now, a lot of programming editors do what's called syntax highlighting, which is a way of saying we're going to color things. We're going to color the different parts of speech of the language. This particular part of speech in green that starts with the number sign or pound sign or hashtag is called a comment. This basically says to the computer, ignore this. This is for humans only. Comments are very useful because they can remind you of what the heck you did a week ago. Okay, so this tells us that what we're going to do first is get the height and width of the image. And it's literally just written for human eyes to kind of see this. Okay, I could delete this and it has no effect on the program because it's comments. It's meant for humans only. The computer will ignore everything to the right of this sign. Okay. Width equals image.getWidth, open parentheses, close parentheses. And height equals image.getHeight, open parentheses, close parentheses. So we get to our first operation here. I will go into detail more on this in a week or so, but this equal sign is called the assignment statement. It uses the equal sign to say, basically, to almost say that we're setting these two things equal. In reality, what we're going to do is we're going to be taking the thing on the right and storing it in the thing on the left. Imagine width is a box, that we are basically creating a box labeled width, and we're taking this and storing it in there. Now, the parentheses are what we use to basically say, hey, this get width, it's a verb, it's a function. The parentheses are the way of saying, I want to run this function rather than talk about it, right? Like I can talk about bouncing a ball versus actually bouncing a ball, right? So I can talk all I want about bouncing, but if I actually want to bounce something, I have to do it. And the parentheses are the way to tell the program actually do it. We formally call this invoking a function, which I love because it makes us sound arcane and wizardly, right? So this basically says, hey, get the width of the image and get the height of the image. Images, what does that mean? It means it's saying how big it is. Now, images on computers, now this is a fun aside I get to do. Images on computers are measured not in inches, not in metric units, but in something called pixels. Okay, and we see that word over here later on, get pixel. And what is a pixel? Pixel is short for the term picture element. Let's go ahead and go to Wikipedia. Pixel. No, not that pixel. This pixel. Right? The smallest element in an image. Right? Any image on a computer is made up of squares. And we can kind of see that here as we zoom in, that any image on a computer or on a screen is made up of squares. When we talk about an HD TV that is 1080p, we mean that has 1080 rows of pixels, right? There's 1080 rows of pixels, right? And in fact, and this gets harder every year because, especially for the Macs, because they just love to simply just stack tons and tons of pixels into a small screen. But if you get really, really close to your computer, like really close, you can see, oh, this thing is made up of little tiny squares, right? Any image you see on a computer is made up of these little tiny squares that kind of tricks your brain into thinking, hey, we've got these curves. Now, if we go into even closer on a screen, these individual blocks of red, green, and blue, that's what a pixel is actually made of. It's made up of these, what we call subpixels, right? Okay, which I'll get to in a minute. So it's made up of 3 lights. Each of the squares is made up of 3 lights, so small that you cannot see them. Okay. Okay. Now, as I mentioned, your screen and any image is just kind of a box of pixels, right? It's a collection, and they're collected into some box, right? Some rectangular object. And so we say, so what we have over here are 2 for loops. These are iterative statements, and they will be the primary focus of week 3 through the second half of week 3 through week 6, and they will be the primary focus on your first exam. You don't have to learn them yet. I'm just telling you what's coming up and what we're going to be emphasizing. And these are the ability to, what they do is that they give us the ability to automatically go over a collection of things. So for here, what we're saying is go over all the pixels, every row and every column, in this image, right? So what we're doing is we're generating all possible row-column combinations that are valid for how big this thing is. I'm not going to go into what all that means, the 4 row and column range height, what does that range mean, what does in mean, right? But it's readable, right? You can read it technically. Doesn't necessarily mean you can understand its meaning or even grok it, but you can kind of get it, right? So it's going to go through all possible pixels, and then it's going to get that pixel from that image, saying, hey, get the one at that column row. It does column first because this is a very annoying thing, right? Row and column, right? We talk about things like matrices in terms of rows and columns, but the row is the y coordinate, right? Rows are y coordinates, and the column is the x coordinate, left to right. So that's kind of always threw me for a loop, and I would have to kind of correct your, and I've had issues where I'm like, oh right, I have to flip that. So anyway, what we do over here is that we do p.getRed, we say to the pixel p, get red, get green, get blue. That's what this statement is doing over here. By the way, it's saying get the pixel at that row and store it in p. So here we say get the red value, the green value, and the blue value. Now, let's go back to our image over here of pixels. Each of these pixels, I said, is made up of 3 lights. And what it's doing is those 3 lines do is that they get the amount of red, the amount of green, and the amount of blue. We color with light on a computer, which is a bit different than coloring with ink. It's so weird, but because you don't really think about it, right? If you take a bunch of crayons, right? I mean, think back to elementary school and stuff. You take a bunch of crayons, and I'm sure you've done this, where you just take a bunch and you just scribble them all over the place. You end up with black or very dark red, right? But if I keep shining more and more and more light at you, you get white, right? Whereas if I turn off the lights, that's when you, in other words, less light, that's how you get black. So you'll know. So as you work with color, you'll find like, oh, it doesn't do exactly what I thought it would do, like with mixing these 2 colors. But what we do is we add light. Now, what we do is we typically, these values for light, they run they have a range. That range is 0 to 255. Why? Because that's how much you can store in 8 bits, 8 zeros and ones. Why is that the case? Discussion for a later day. Just know that it goes for that a value of a light is between 0 and 255. Okay? And that tells us basically a range from this light being all the way off to all the way on. Make sense? So if all these values are 0, like over here, we see that these are going to be black. And you can see that this is going to kind of be gray. Now, what this algorithm will do, what this verb will do, this function, is says, we're going to add all these values, the red value, the green value, and the blue value together. And what we're going to do is we're going to get their average, right? How do you get an average of something? If I have 3 items, I add them together, I just simply divide by 3 to get their average value, right? Just like if you have 2 siblings, to get your average age, you add your ages together and divide by 3, right? Okay, so this is what we call an if statement. It makes a decision. It says, if it's one thing, we do this, otherwise we do this. And what it's saying is that, hey, if this value is 255, divide by 2, in other words, it is on average more on than it is off, because 0 is off, 255 is on. If it's closer to being on than it is to off, we're going to just turn them all on. We're going to go white. Otherwise, we're going to set everything, we're going to create these 3 variables, and they're going to be 0. We're going to create a new thing that's black. Then we create a new pixel, and we just swap out the old pixel with the other one. So let's go ahead and run this and see what happens, right? So we see this Luther College bell, and it's going pixel by pixel across and looking at every single pixel and saying, hey, is this greater than half on or less than half on? If it's greater than half on, we're going to set it to white. If it's less than, we're going to set it to black, right? We can make pretty good guesses, like this bell is going to end up being black. Everything's going to get turned off for it because it's very dark. Whereas we can see like some of the bricks, the bricks are more lighter, so they get turned off, but we kind of see the outlines of them, right? And this is what we call a black and white image, as opposed to grayscale, which is what you typically think of when you think black and white. And this takes a while to run, yes, partially because we're on the web, but also because of these little commands here, right? What goes on here is we have this image, then we have defining the term, we define what process 11 does. Then over here we say, hey, we're going to load up this image as our image. We're going to set a delay for displaying it. Then I'm going to create a window to display it in, and I'm going to draw it, and then I'm going to run the verb, this process 11, on it. Okay? I know that was a lot to take in. I'm not expecting you to understand it all. If you did, awesome. But if you kind of vaguely understood it, awesome as well. Right? The entire point of this was just simply to try to demystify this. You can kind of look at something and use a bit of doing a bit of search engine stuff to kind of figure out what's going on. Right? To get full credit on this, by the way, this is a bit annoying. What you're going to have to do is you're going to have to do what I just did, which is there's this blank box over here. You'll just have to hit show code and hit save and run to get full credit on this assignment. And what it will do is that this will just simply show that you interacted with this box. Okay. So do that, and then we'll move on to the actual task for the day where you get to have me finally shut up and you can actually do something interesting. So we have two pictures here, yawningsquirrel.jpg and lutherbellpic.jpg. We have 10 functions, and what the second box over here is it defined all these 10 functions, process 1, process 2, process 3, all the way down to process 10. So we have 10 of them, right, over here that are defined. And then we have this other box here that you're going to work with. And it's very simple over here what this code does. It says, here's our original image. We're going to be using the yawningsquirrel.jpg. We're going to run one of these functions on it, okay? Then we're going to generate a new image, and then we're going to draw that new image. Now remember what I said early on. All you're going to be doing is changing a number and hitting the run button. This is the run button. This is the number you're going to be changing. That's pretty much it. Because our goal is we're going to try to see, this is how we can change code. Because I get a lot of students sometimes, because basically we get two kind of problematic habits from students when they just start out that end up leading into trouble. The first is what I call spaghetti coders, where they make code and and they run into errors and they keep coding even though they still have those errors, and they don't go back and fix the mistakes they previously made, and their code becomes this giant tangle of spaghetti that's hard to untangle. It's hard to work with, right? And that one is, not great, but we can at least work with that because you're trying and you're doing something and you're experimenting, and yeah, it's getting to be a big mess, but like making messy things is how you learn, right? That's what Miss Frizzle says, at least. So, as the other end, right, this is what we're trying to get away from with today's experiment. A lot of students also treat the other bad habit is what I call bomb coding, which is they treat their computer like it's a ticking time bomb, and if they make one mistake, they're going to blow everything up, right? At least in Runestone, that's not going to happen because you can always revert to the original, right? If I completely mess this up again and again, oh gosh, right, and it's just going to give me more errors and stuff like this, I can always revert to the original, always. So don't worry about messing it up. You can't mess it up beyond all repair, I should say. So let's see what this does, right? What it's given to us. This will run process 11 on our image. So there's our squirrel. Let's see, come on. And then it turns that squirrel image demonic, I guess. It's not really a good, I mean, it's a good description for what it did, but it's not necessarily accurate as for what it would do to any image. Would it turn any image demonic? How does it do that? Well, below we have a good old-fashioned drag and drop, right? And your task is to match up these functions, right, whatever they are, to the appropriate effect. So you take the thing on the left and drag it onto the right, right? That's your task. And you figure that out by running it. Now, if you can, and I'm going to give you 10, 15 minutes to do this, and then when we're done with that time, I will come back and I will go through them myself and show you. Now, the biggest headache you're going to get, and I apologize for this in advance, is you'll notice here that basically we have verb, process 10, it works on an image. Process 8, right? If I change this to process 1, it works on an image, right? Process 1, this is what process 1 will do. It doesn't make it demonic, it does something else. But when we get to process 5 and process 6, they say you need an image and a number. So let's just kind of nip this in the bud. Okay, process 5, I hit save and run, it's going to yell at me saying it's missing one required argument. And if we look at over here, it says you need an image and a number. So let's see how to do that. You put in a number, and I recommend using very small numbers like 1, 2, 3, 4, those kind of numbers. And now it will run because it has that number. Process 6, similarly, right? You need 2 numbers. Right, and then it will run. Okay? Doesn't actually do anything with 1 and 1, so you have to experiment. So take the time and figure out which of these 10 go to the other 10. If you finish, you can go ahead and go on to the next part, which is kind of chaining these processes together. But again, this is kind of like trying to get you to see this is how we run Python code. You can make changes to it. This is an important thing to understand because as a programmer, you will be doing this all the time. You only have to understand a little bit of what's going on to use it sometimes. You don't have to look under the hood all the time. Just how you know how, if you drive, just because you're driving a car doesn't necessarily mean you understand what's going on with the combustion engine, right? It's a black box. So you can kind of take that to heart. So I'm going to go ahead and pause. Feel free to work and talk with the people next to you, right? This doesn't have to be a solo exercise. Feel free to be social. I'm going to go ahead and make my way around the room, and if you need help, just let me know. Understanding how this textbook works. So let's go ahead and actually go through these. So I'm going to start from 1, and I'm going to go through them one at a time. And when I'm certain about something, that's when I'll drag it in. Because the last time I looked at this was the beginning of last semester in spring. So I don't have it all memorized. Let me go ahead and get back to our original state. So process 1, running on it. Let's see. So this is our original image. What does process 1 do? Not sure. Looks like the corners got darkened a bit, right? Maybe it's this, but I'm not certain enough to say. So I'm going to go on to process 2, right? Because I can always go back to it. Nothing says I have to do them. Okay, this one I'm a bit more certain about because look at this. Look at this thing, and look at this now, right? We've got the dark stuff getting really black and the lighter stuff, like his little tummy, getting really white. I'm fairly confident it's this. And I can always move them around if I'm wrong, right? Adds the Clarendon type effect. Darker's darker, lighter's light. Okay, so let's move on to part 3, right? 3, let's see what 3 does. Oh, this one's fairly straightforward. So this is what we call grayscale, right? So you get grayscale when you get something that's gray when those 3 light colors are all equal to each other, okay? So you technically get 256 different shades of gray on this kind of screen, right? It's not black and white, even though we typically say black and white, or it's a bit more, you get a bit more nuance in that, right? So, but process 3, that's grayscale, right? And if you don't know what these terms mean off the top of your head, always just feel free to look them up, right? Or ask me, right? Grayscale isn't necessarily something you would know because we like color. But unfortunately, color wasn't invented until the 1950s when we got to start seeing it on TV. So this one seems fairly straightforward. I put it in, I ran it, and the squirrel went sideways. Let's see. It doesn't say anything about going sideways. It uses, but we've got a more mathy term. It rotates it by 90 degrees, right? Specifically by 90 degrees. It doesn't rotate by multiples of 90 degrees. Technically, that doesn't seem as accurate because multiples, this is a multiple, but multiples implies that we could do different options. So process 4 rotates by 90 degrees, definitely. Now, process 5 is one of those two tricky ones I said, right? If you try to run it like this, it will yell at us saying, you can't do that, right? It says type error, process 5 missing one required argument, number. And fortunately, our book sometimes gets a bit more descriptive, saying, hey, let's go ahead and try, and when you try to combine this, that's not what happens there. Missing one required argument. So let's put this in. So we need to put in a number. If I put in 0, I get nothing happening. If I put in 1, I get 90-degree rotation. And if I put in 2, with a bit of experimenting, we can see what's going on here. We get an upside down squirrel. So definitely process 5 is rotating my multiples of 90 degrees. Now process 6, again, was one of those ones that was weird that I pointed out right before we started. It requires 2 numbers. It requires our image and 2 numbers, right? So if these trip you up, don't feel too bad. I honestly wouldn't have included them had I made them because I would have tried to keep it as consistent as possible. But some verbs, they take in one thing, some functions take in no things, and some take in like multiple things. So here we take in an image and 2 numbers. So I'm going to go with process 6, and I'm going to match it up with what it has below, which is, so I'm going to pass in original 1, 2. Process 6, 1, 2, and our squirrel got nice and squeezed, right? Got longer, and this stayed the same amount wide, but it got taller. Let's see if any of these apply to here. Added vignette effect, converts to only black, white, red, blue, and green. Enlarges in X and Y, converts to high contrast, lightens, darkens. Enlarges in X and Y, that's the only one that fits. So the first number must be the X and the second number must be the Y, and how much it got stretched by. Process 7. Process 7. What does process 7 do? Oh, I think we've seen this one before. 7 is, it's only black and white. So let's go ahead and find that. Process 7, high contrast, black and white only. Process 8. Process 8. Okay, process 8 versus process 9. So that made it kind of lighter. Process 9, right there, process 9 makes it kind of darker versus process 1 which only made the corners darker. So that gives us our answers. Process 8, I said, made it lighter. Right, process 8 makes the whole thing lighter, so we've got lightens image and darkens image. So 8 makes it lighter. 9, if we go back in memory, and if you didn't see that, go ahead and rewind. Sorry, mine's getting pretty big. So I'll go over here, process 9, drag it over here. And then we have process 1 and process 10. Process 1, we were able to kind of see what happened. That darkened the corners. That's our vignette effect over there. Right? And process 10, our demon squirrel, right? Let's go ahead and let it run. converts to only black, white, red, green, and blue. It's a process of elimination as to what it is, but we can actually see this. In effect, we've got black, we've got white, we've got green, we definitely have red, and even though it's hard to see, we do have a little bit of blue right here on the eye. It's hard to see on the big screen, but if you run it on your own computer, you can see there's a single blue pixel right here. Like I can see it perfectly on my screen. Projectors don't always have that kind of color contrast. Okay. So, and then we'll hit check me, and it says I'm correct, which I would hope I would be, right? Now, now the fun thing we can do is that we can chain functions together. We don't necessarily have to do one. There's nothing stopping us from kind of just chaining them together. And here we're not asking you to figure out any specific task. Here we're asking you to experiment as the last part of our lecture for today. So, right, now you could do something like this where basically you say process 1 on process 4 on image, and you could chain them together into like this big compound statement. But just like how compound statements can be complex and to do that kind of grammar diagram in English class, right? And that does kind of show a mastery of the language. It is harder to read, especially for beginners. So, especially in this class, if you're a more experienced programmer, you're going to notice that I break up statements that could essentially be one line into something that maybe even 2 or even 3 or even 4 lines, just so that they're easy to read. Because, and this is an important kind of principle in Python, code is read a hell of a lot more times than it's written. Right? You write it once, but even if you're solo programming, it's going to be read multiple times by you. Here, I've got over 100 eyes on it, right? So I got to make sure that it's as easy and as painless to read as possible. So I will often break this up, especially at the beginning of the semester, rather than doing something like this. What I'll do is I'll break it up into multiple parts. So let's go through this. Right? We start with our original yawningsquirrel.jpg as our original. And what we say over here is, in line 3, we say process 1, we run process 1 on original. We take the output of process 1, this is what the equal sign does, it says we're going to take what's on the right and store it in the box on the left. Okay, you're going to hear me say that a lot. And if you have me for 2168, you're going to have me basically shouting that at you because when we get to stuff like references, which you don't have to deal with in this class, but when we get there, it's 2168, class 3 in programming, essentially, third programming class. That's where it really becomes important to understand that we are not setting two things equal to each other like in math. We're not like saying x is equal 5. What we're saying is thing on the right gets stored on the left. Process 1, original, the output of this gets stored in step 1. Then we take what's stored in there and run process 4 on that and store that in final. So we basically start with our original, turn it into step 1, and then step 1 gets turned into final. So we can run this, right? We see run this, and these two lines just run it. So we get the vignette effect, and then we rotate it, right? Step 1 was vignette, process 1 was vignette, process 4 was rotate by 90 degrees. So we could ostensibly do something like this, by the way. We could do something like step 2 is equal to process step 1. Which process should we run? Process 9, right? And the important thing here is that I'm adding kind of an intermediate step in here, right? Take the original, turn it into step 1, take step 1, put it in step 2. The key to remember is that then, just because I put it in there, that if I run this, it's going to go and do exactly the same thing as before. Because remember, your computer is an evil genie. It will do exactly what you tell it to do, not what you meant, right? So it runs and it rotates. But it doesn't run step 2. Sorry, we don't see step 2 in there because I didn't tell it to run on step 2. I just kind of skipped over that part, right? I said, hey, take step 1, run it through process 9, but also take step 1 and run it through process 4, right? So kind of have to chain them together like that, right? Because we're saying take this and run it through there. And what it does is it creates a new image. It doesn't change the old image, it's creating a new image. It's copying it and making a change. So vignette, darken it, and rotate. Right. So go ahead and play around for it, and be sure to answer these questions on the bottom. Okay? And then when you're done with that, you're free to go. Okay? And if you have any questions, feel free to come down over here and talk to me. All right. Have a great day. And hopefully your first week will be nice and unstressful.